Good morning, one and all. I am Dr. Sirisha Devi, working as Associate Professor in Institute of Aeronautical Engineering. In our previous classes, we have seen about the introduction of data structures. We have seen what are the various applications of data structures and what kind of data structures we find generally, just like linear and non-linear data structures we have seen. And we have seen the basic operations that we perform on data structures, and we got an introduction of searching techniques, linear and binary searching techniques. In this session, I would like to start with sorting. Sorting techniques. We are going to see the major three basic sorting techniques that we perform on data structures, right? So what do you mean by sorting? Arranging of the data in either ascending or descending order is nothing but a sorting technique. Just like you make it as increasing order or in decreasing order, in either way, it will be sorting. Placing them in an order is nothing but sorting. Yeah, we do require it at times. As we have seen in a binary search, the prerequisite for that is a sorted list, right? So to conduct any binary search, the list which we want to search must be sorted first, right? So let's see the first three basic sorting techniques. First one is a bubble sort, insertion sort, and selection sort. Let's start with bubble sort. It is the most simple sorting technique that you will find. Yes, it is simple. Comparing two elements, adjacent elements, I can say, adjacent elements, and swap them if they do not follow the condition of less than or greater than. It all depends upon whether in which order you want to place the elements, either in ascending or descending, right? So what we have to think of when we are talking about a sorting algorithm, we need to think of what is its time complexity, space complexity, whether it is stable one, in place. These are all the factors which influence any sorting algorithm. Here, the best case time complexity of our bubble sort is order of n. Average case is order of n square. Worst case is order of n square. And the memory it uses is order of 1. One temporary variable is enough just to swap the elements. Generally, when we swap two elements, we need a temporary variable to store the intermediate one. It depends. In C language, we do need that, right? Right. It is a stable and it is an in place. We don't need any temporary array or a list of the same size to store the data. No, in whatever the unsorted list which we are given with, we are going to place the elements, we are going to swap the elements in that list itself, and we are going to sort them. Such is a bubble sort. I'll explain you with an example. Please have a look. Yes, the algorithm, how it goes. A simple explanation. Always it starts with an index 0 value. Compare the next element or an adjacent element to it. That is an element at index 1. If the current element is greater than, the current means the one which is pointed by our index value 0 is greater than. I'm talking about, guys, please remember, I'm talking about sorting the elements in ascending order, in an increasing order. Okay, right. So the current element, that is the element which is at index 0, is greater than the element at index 1. We swap the elements. Repeat the same, go to step 1, repeat the same unless you reach the end of your list, right? This is the simple algorithm for your bubble sort. Let's see the example. First iteration. Then you might be thinking, what is an iteration? Iteration is nothing but a step, a single step in which we come to a partial solution. So let's see this example. I have taken 5 elements, 21, 54, 36, 18 and 29. Yeah, this is an unsorted one which we have to sort now. Yeah, as I said, first compare the element with, yes, if you consider this one, 21 at index 0, 54 at index 1 and 36 at index 2. 18 at index 3 and 29 at index 4. Totally 5 elements are there. So first I'm going to start with the current element is my element pointed by index 0. That is the element 21. The adjacent element to that is at index 1, which is 54. Compare these two. Is 21 greater than 54? No, they are in order. Guys, remember I'm talking about ascending order. They are in order. So I need not swap them. What next? Compare the elements. Increment the I value. Increment the value. So now we are going to consider, now the current I element will be at index 1. Right? Index value 1. So adjacent element to that will be, next element to that will be at index 2. Compare these two. Is 54, yes, is 30, get the relation between 54 and 36. 54 is greater than 36. What do you mean by that? Do we need to swap these two or not? So swap 36 and 54. This will be the resultant list. So 21, 36, 54, 18 and 29. Got it? Yes. Now, same process is repeated. Now, shift the pointers. Now, the current index is at index value 2. Current element will be at index value 2, which is 54. Next, what? The next element to that is at index 3. Compare these two. Again, there is a mismatch. What I was thinking of, that the element at 2 must be lesser than the element at index 3. But the rule got violated over here because 54 is greater than 18. So swap these two elements. This is the resultant list you are going to get. Right? So again, shift the pointers. Now the current element is at index value 3. And the next element is at index value 4. Compare these two. Again, a violation of rule. 54 is greater than 29. Swap them. So once you swap it, you are going to get this list. 21, 36, 18, 29, 54. According to the rule of bubble sort, what you are supposed to do? You are supposed to shift the pointers. Now the current element will be 54 and its next element. But when you go for the next element, are you going out of your limits or not? Because 54 is the 54, or you can say, or the index value 4 is the last element in your list. You have reached to the end of your list. So by this, we can say that it is end of iteration 1. End of iteration 1. Very good. You said, ma'am, that by the end of every iteration, we are going to get a partial result. Where is the partial result, ma'am? I'll show you what the partial result is. You can see that largest element is its right position. Forget about the remaining elements, but in the current list, the largest element is in its right position. That is the last position. That is the success we got after iteration 1. Okay. So the last step, or the list which we have in our hands, becomes the first step of our iteration 2. Okay. Iteration 2. So I hope you can see the change in the color. I have fixed the position of 54. That is the beauty of bubble sort. With every iteration, it brings the largest element in the list to its right position. Guys, got it? So let's start iteration 2. So now this is our current list. So again, start the same process. Compare between 21 and 36. Is it violating the rule? No, 21 is less than 36. Not a problem. Shift the pointers. Comparison between 36 and 18. Comparison between 36 and 18. It violates the rule. 36 is greater than 18. Swap those values. Once you swap those values, this is the list which you are going to get. 21, 18, 36 and 29. Forget about 54. I have removed it from my point of concept. It is, I can say that the major list has shrunk into a sublist. Means if the actual one was having n elements, in the second iteration I will have only n minus 1 elements. Right? So now my point of concentration is 36 and 29. Compare between these two. 36 is greater than 29. It is violating the rule. Swap them. Once we swap them, I hope you can see that even 36 has come to its right position, which is the second largest element in your list. So even it has freezed its place in the iterations. Right? In sorting, it has freezed its place. So what is the success you got, ma'am, after iteration 2? We got the second largest element in the current list. Right? So now let's start iteration 3. Then what will be the input for your iteration 3? The current list. Where is the current list? The current list is this list, the last one which we got, right? That will be the input for the next iteration, iteration 3. Have a look at the list. 21, 18, 29, 36 and 54. So as this is iteration 3, two iterations we have completed, 2 elements have come to their right positions, 54 and 36, and they are freezed. So we have to think of only the sublist that we are having in our hands. So let's start the process. Compare between 21 and 18. Compare between 21 and 18. Is it violating the rule or not? Exactly, it is violating. Yes, it is violating. 21 is greater than 18. Swap them. Okay, once I swap them, my current element will be 21 and the next element to it will be 29. Are they violating the rule? They are not violating the rule. It's fine, right? So 21 is less than 29. So they are in order. I need not swap them. So what next? That is the end of the list, because what did I tell you? With every iteration, I am going to fix one element's position, right? So then elements gets shrinked. If in the first iteration, if there are n elements, the second iteration n minus 1 elements, third iteration n minus 2 elements, right? So this is the end of iteration because 29 was the last element in the sublist. So what is the success? That is the partial result which we got. We can see that 29 has come to its right position in the final sorted list, which is third position, right? Okay, then let's go for the next iteration. Because still we have elements in our list. We have to continue this process. Iteration 4. What will be the input for iteration 4? The last current list which we got by the end of iteration 3 will be the starting list in our iteration 4, right? So this is the current list where 3 large elements in the current list are freezed because this is iteration 4. Let's start the process. Compare between 18 and 21. Are they in sorted list? Yes, they are in sorted list. Do you need to change anything? I don't think so. You need to swap anything? No. So this is the list. 21 was the last element in the current sub list. So now 21 is placed in its right position, which is the 4th largest element in the list. Right? So now think of the logic. So only one element is there in your list or sub-list which need to be sorted. Do you have any other element in your hands to compare? No, right? So this is the end of iterations. Remember, in bubble sort, the funda will be, if there are n elements, then you will have n minus 1 number of iterations. Please make a note of this one. If in bubble sort, if we have n elements in the list, then we will have n minus 1 iterations. Why? Because we need not compare the last element with any other element to sort, right? It gets sorted. It is in its first position. We need not compare it with anyone, right? So what are the final sorted list? Yeah, this is the final sorted list that we have. Yeah, this is the final sorted list that we have. Okay. So where did we get the final sorted list, ma'am? This is the last list which we had by the end of n minus 1th iteration. That is the end of 4th iteration in this problem. This is the final one. Guys, I hope you understood what a bubble sort is. It is quite simple and straightforward sorting technique where we compare two adjacent elements if they are not in an order in which we have taken, that is either less than or greater than. It depends upon ascending or descending order, right? Okay, let's confine ourselves to ascending order. Okay, if the two adjacent elements do not satisfy the relation of less than, then we swap the elements. With every swapping or non-swapping, we shift the points of concentration, the current element and the next element. And one most important point that you have to remember is, by the end of every iteration, the largest element of the list is going to sit in its right position, right? So, in placement's point of view also, will be a very important one, because obviously no one is going to give you an unsorted list and ask you what is the sorted list for this one, right? So, but they will be asking about what will be the partial result after third iteration. If say the list is having say 10 elements, they might be asking what will be the partial result after 5 iterations. Yes, in many competitive exams, you might have seen that, right? So how many, bubble sort, there are 7 elements in the list. How many iterations you need to sort using bubble sort? Remember, n minus 1 iterations. So 6 iterations. Right? So these type of questions you might be getting in MCQs, right? And in theoretical point of view, in an algorithm or an unsorted list will be given to you, and they'll be asking you to show all the iterations, that is all the partial results. I hope you understood. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.